What is coaxial cable? Coaxial cables, commonly called coax, are copper cables with metal shielding designed to provide immunity against noise and greater bandwidth. Coax can transmit signals over larger distances at a higher speed as compared to twisted pair cables. The advantages of coaxial cables. It can be used for both analog and digital transmission. It offers higher bandwidth as compared to twisted pair cable and can span longer distances. Because of better shielding in coaxial cable, loss of signal or attenuation is less. Better shielding also offers good noise immunity. It is relatively inexpensive as compared to optical fibers. It has lower error rate as compared to twisted pair. It is not as easy to tap as twisted pair because copper wire is contained in plastic jacket. Disadvantages of coaxial cables. It is usually more expensive than twisted pair. What is spherical shell? In geometry, a spherical shell is a generalization of an annulus to 3 dimensions. It is the region of a ball between two concentric spheres of differing radii. A thin spherical shell of radius A has a total charge Q distributed uniformly over its surface. As shown in the picture, consider a thin spherical shell of radius R with a total charge Q distributed uniformly over its surface. For points outside the shell, R is equal or greater than capital R. The spherical Gaussian surface will enclose the thin spherical shell, so Q in is equals to capital Q. For points inside the thin spherical shell, smaller r is smaller than capital R. The charge lies on the surface of the thin spherical shell. No charge is found within the shell, so Q in is equal to 0, and the electric field and flux within the thin spherical shell is also 0. Coaxial resistor. Two perfectly conducting coaxial cylinders of length 1, inner radius A and outer radius B are maintained at a potential difference V and enclose a material with ohmic conductivity or as in figure below. The electric field must then be perpendicular to the electrode so that with no free charge, Gauss's law requires. The equation below, where C is an integration constant found from the voltage condition. The current density is 10, shows in the equation below, with the total current at any radius R being a constant. Equation shows so that the resistance is R equals to V over I. Spherical resistor. We proceed in the same way for two perfectly conducting concentric spheres at a potential difference V with inner radius R and outer radius R2 as in figure below. With no free charge, symmetry requires the electric field to be purely radial so that Gauss's law yields. The equation shows where C is a constant found from the voltage condition S. The equation shows The electric field and current density are inversely proportional to the square of the radius. And then we get this equation so that the current density is constant at any radius r. In the equation like this with resistance.
So for the solution example, a metal bar of conductivity sigma is bent to form a flat 90-degree sector in inner radius A, outer radius B, and the thickness T as shown in the figure. Show that the resistance of the bar between the vertical curve surface at R equals to A and R equals to B is the given R equals to 2 B over A over sigma pi T. So the solution is, we use the cylindrical equation. So this is the cylindrical equation. Since V equals to VR, so we need to derive V equal to 0. So first we need to multiply both sides with R, and then we'll integrate both sides. So we get the R dV over dr equals to A. This is we consume as a constant. So we substitute A into the equation and we integrate again both sides. So we get the V equals to A ln R plus B. B is the second constant for the second integration. As we know, R have two variable, which is R equals to A and R equals to B. So first, R equals to A. V R equals to A equal to 0. 0 equal to A ln A plus B. So we rearrange in term of B. B equal to negative A ln A. While R equals to B, so V RB equal to V naught. V naught equal to A ln B plus B. We substitute B by we get this. So V naught equals to A ln B minus A ln A. So we will get V naught equal to A ln B over A, because when ln minus, so in ln term will be divide. So we rearrange in term of A. A equal to V naught over ln B over A. Since V equal to A ln R plus B, so we substitute the A and B into the equation. So we get V equal to V naught over ln B over A ln R over A. After we get V, so we need to find the E, which is electromagnetic field. Because if we need to find current, so we need to find E first. So E is equal to negative dV over dr AR. So we substitute the V, which is V naught over ln B over A ln R over A. So we rearrange the equation. We put ln B over A outside and V naught. So the ln RA we will be differentiate. So we will get 1 over R. So E equal to negative V naught over R ln B over A. So after we get the electric magnetic field, so we need to find the current. So this is the J equation and the S equation. So in current, we will calculate integrate J ds. So the range 0t is for Z, and 0 until pi over 2 is equal to R. So we integrate all of this and we will get pi over 2 T V naught sigma over ln B over A. And after we get the current, so we will use Ohm's law to calculate R. So the Ohm's law given R equal to V over I. So we insert V and I into the equation. So we will get R equals to 2 ln R over A over pi T sigma. So this is the correct answer.